In this video, we'll look at the expansion of a plus b to the power n and play with it. We'll change the values of a and b to get some special cases. So let's first quickly look at the expansion. A plus b to the power n, that's actually equal to this. This is summation k equals to 0 to n ck a to the power n minus k b to the power k. What this means is we have a summation, which means we're adding a lot of terms. The summation is from k equals to 0 to n, which means k moves from 0 to n. And for different values of k, we'll get different terms. How many terms do we get? Well, from 0 to n, we have n plus 1 integers, which means we have n plus 1 terms. Each term has a coefficient, nck, that's the coefficient. Then we have powers of a, and then we have powers of b. All of this makes a term, and if we sum all of them, we'll get the expansion for a plus b to the power n. So let's do that. When you expand it, this is what you get. These are the terms, and you add them up. So this is the expansion for a plus b to the power n. Let's quickly look at the coefficients. For k equals to 0, the first coefficient is nc0. Then we have nc1, nc2, and so on. This goes on to ncn minus 2, ncn minus 1, and finally ncn. Now let's look at the powers. The first power of a is n, because for k equals to 0, we have n minus 0, that's actually n. So we start with a to the power n, then we have a to the power n minus 1, a to the power n minus 2, and so on. The powers keep on decreasing, so on to a square, a to the power 1, and finally a to the power 0, that's actually equal to 1. For b, we do this in reverse. We have b to the power 0, which is 1, then b to the power 1, b square, b cube, b to the power 4, and so on. And the last few powers are b to the power n minus 2, b to the power n minus 1, and finally b to the power n. This is your expansion for a plus b to the power n. Now let's play with it. The first thing that we can do is change this value of b to minus b. By doing this, we'll get the expansion for a minus b to the power n. So let's do that. A minus b to the power n, that's actually equal to summation k equals to 0 to n, everything remains the same, and then finally we have minus b to the power k. The only change is that from b, we move to minus b. So let's see how this changes the expansion. The first term is nc0 a to the power n, because there's no b, so nothing to worry about. The next term is nc1 a to the power n minus 1, and for b, we have minus b. So this becomes minus b to the power 1. The next term will be minus b square, and so on. The last few terms will look like this. Everything remains the same except b, because for b, we have minus b. Adding all of them up will give us the expansion. Okay, so what changed and what remained the same? nc0 a to the power n. That's exactly the same thing. This is what we get for a plus b to the power n. What about this one? Is it same or is it different? Well, that's different, because this minus sign can come out and we can say that we have a negative term here. The next one is a positive term. Why? Because b square is b square and minus b square is also b square. This negative sign is important, but this even power is also important. This even power eats up this negative sign and we get the same term. This is exactly what we get for a plus b to the power n as well. Then we have a negative term, and then a positive term, and negative term, and so on. So to summarize, we have roughly half the terms as the same, and the remaining half will have a negative sign. Which terms remain the same? Which terms will have the negative sign? Well, that depends on the power of b. If we have an even power of b, we'll have the same term. For example, b square, b to the power 4, b to the power 6, and so on. But if we have an odd power of b, we'll have a negative term. Here we have negative b to the power 1, which means we have a negative sign here. What about the last term? Will it be positive or negative? Well, we can't say, because we don't know the value of n. We don't know whether it's even or odd. So depending on the value of n, we might get a positive term or we might get a negative term. We can write this negative sign out. We can write this as negative 1 to the power n, ncn b to the power n. So this stuff is the same. This stuff is new. We have added minus 1 to the power n on it. Okay, so this is the expansion for a minus b to the power n. Next, we'll put in some values for a and b to get two more special expansions. Let's see. The first was a plus b to the power n. This was its expansion. Then we had a minus b to the power n, and this was its expansion. Everything the same except for b, we have minus b here. What can we do with a and b? Well, we can put in a as 1 and b as x. We'll get 1 plus x to the power n. That's a very useful expansion. If you do the same thing here, we'll get 1 minus x to the power n. Replacing a as 1 and b as x, the summation will look like this, and for this one, it will look like this. Because 1's powers are just 1's, so we can completely ignore this part. We can simplify this. We can say that this expansion is actually nck x to the power k, and this one is nck x to the power k, but with an alternate negative sign. Let's see what the expansions look like. For the first one, we have 1 plus x to the power n. Okay, the first term will be nc0 x to the power 0. Then we have nc1 x to the power 1, nc2 x square, and so on. The last term will be ncn x to the power n. What's going to be the expansion for 1 minus x to the power n? Well, it's going to look like this. Exactly the same thing, but with alternate signs. So let's do that. nc0 x to the power 0, and then a negative sign, nc1 x to the power 1, and then a plus, and then a minus, and so on. And we don't know the last one, so we'll keep it like this. Minus 1 to the power n, ncn x to the power n. So comparing these two, we have same terms, and then negative term, and then negative term, and so on. So the first term remains the same, the third term remains the same, the second one alternates, the fourth one alternates. So it depends on the power of x. If we have an even power of x, things remain the same. If we have an odd power of x, the sign will be flipped. From positive, we'll go to negative. What can we do now? So now we have two more expansions, 1 plus x to the power n and 1 minus x to the power n. We get two more special results if we plug in a specific value of x. And that value is x equal to 1. Go ahead, pause the video, see if you can figure out what we get when we put in x equals to 1 in both these expansions. Okay, so let's do this together. Let's write down the expansions. This is 1 plus x to the power n. This is 1 minus x to the power n. Okay, so now let's put x equals to 1. We have 1 plus 1 to the power n. What do we get on the right side? Well, we have these different powers of x, but x is 1 here. Any power of 1 will still be 1. So we can completely ignore all the x written here. All we are left with are the coefficients. So 1 plus 1 to the power n is actually equal to nc0 plus nc1 plus nc2 and so on to ncn. So what we actually end up with is the sum of all the coefficients. So the sum of all the coefficients is 2 to the power n. That's a very powerful result. Okay, what do we get here? 1 minus x to the power n. If we put in x as 1, this is what we get. 1 minus 1. And what is 1 minus 1? That's 0. So what do we have on the right hand side? Again, the same thing. Because all the x are just 1s, we can completely ignore them. What we have is these alternate coefficients. nc0 minus nc1 plus nc2 minus nc3 and so on till the last term. So if you alternate them as positive, negative, you actually end up with 0. And if you keep the sign same, if you have all of them as positive, you'll get 2 to the power n. These are two very powerful results.